Welcome to Talkcast. It's been a while since I've done a podcast like this one. In fact, you have to go all the way back to episode 22, The Logic of Experimental Tests, and episode 19, Mr. Popper's Problems. The former, The Logic of Experimental Tests, is a podcast devoted to unpacking an academic paper written by David Deutsch, published in the journal Studies in the History and Philosophy of Modern Physics. And the latter, Mr. Popper's Problems, is a podcast about a paper by Karl Popper called The Nature of Philosophical Problems and Their Roots in Science, which is largely a criticism of Wittgenstein and, well, a defense of philosophy itself against, unusually, philosophers. So with this episode, I'm again departing from the usual style and content of my videos discussing the work of David Deutsch, Karl Popper and associated things in science and philosophy, and am going quite niche indeed once more, a little bit esoteric. I guess because again I'm attempting to turn an academic journal article into a podcast. This is fun for me. I should add, this isn't just me reading the article, by the way. You can do that for yourself. This is a bit of reading and largely my own analysis and comparisons. Anyway, without further ado, let's get into that. The aim of science. What is science? Lots of scientists and philosophers will try and tell you what it is. Many will get parts of it correct, many won't. I don't want to spend too much time criticising all the false theories and explanations about what science is right here and now. Instead, I'm going to look at the best we have. And for that, of course, we can turn to Karl Popper and David Deutsch. But didn't Popper just say it was all about falsification? If you think this, you're on side with so many prominent physicists especially, and science communicators and philosophers, who read a book once where it said, that's what Popper said. But actually, there is more to it, to put it mildly. The capacity for science to be distinguished from things that are not science is indeed drawn by the line we call falsifiability. But although that is a necessary condition, it's not a sufficient one. David Deutsch has explained how we are after good explanations in science, morality, philosophy, history, everywhere. And Deutsch picks up where Popper left off. But where was that? Well, Popper did explain his broader view of science many times, and many times he was ignored, or mangled, or misunderstood, or misrepresented. So it does take people like Deutsch to clarify and refine what he meant. Popper wrote whole books explaining his position. In terms of what science is, or the aim of science, he actually wrote directly on that topic. So that's my purpose here today, to unpack one of his shorter essays, and the essay is called The Aim of Science. Now, this is an essay that I'm about to read in part that appears in multiple places, but you can find it on my website at www.bretthall.org under the title The Aim of Science. The link is in the description to both a clean copy of the PDF and to the PDF with some of my remarks. The essay seems first to have appeared in what is known as the postscript to The Logic of Scientific Discovery. This is Popper's first book, and as many of us who follow Popper have observed, it's not our favourite of his works. It's his least best. One reason I say that it's not his best, is because he is writing for his peers in their language. And he was conceding to them rather a lot that only later people were persuaded was entirely wrong. Popper was sometimes generous in that way, it seems, in going a long way in his arguments and attempts at persuasion and his explanations, at meeting his opponents with an entirely different worldview, at least part of the way. The Logic of Scientific Discovery, his first book, is very dense. It's hard to read. I read it once and I wasn't really inspired to read it again, but I kind of coerced myself into reading parts of it later. And yes, it didn't really stand up to being an inspiring book, even though so much of the new stuff that Popper discovered in terms of how knowledge works is right there in its nascent form. It's just, as I say, expressed in language which is, to me, clunky and tedious. So if I was to make a recommendation about reading Popper, I would say read anything else. The same ideas of his are expressed far better later in his more recent works rather than his most early work, and of course in the work of David Deutsch, where you get a refined, clarified, distilled version of the most important parts of Popper's philosophy. And so what I'd like to do today is to compare some of Popper's work here regarding what the aim of science is with what we now understand the aim of science happens to be. This essay, as I say, appears in other places. It appears in the book Objective Knowledge, and also in a book called Realism and the Aim of Science, both of which are entire books. They're very long. The first, Objective Knowledge, is more a collection of essays, but it's one of my favourite books of Popper's simply because it covers so much ground in epistemology in a really simple way. In that book, Objective Knowledge, he dispenses with induction. He covers arguments explaining realism and compares it to forms of philosophical nonsense. And he refines what might be meant by the word truth and various approaches to truth. And he talks about knowledge without a subject, which is deeply understood by, well, let's say it, anyone who has never understood Popper. And this is what makes Popper the philosopher of objective knowledge. There is that other epistemology called, perversely, objectivism, but it never grapples with knowledge in actual objects, and it still falls back in large part on subjective feelings like confidence and certainty. So it's actually subjective in both senses. Popper's epistemology, on the other hand, is objective in both senses. The book, Objective Knowledge, also touches on Popper's theory of mind, some things about political philosophy and freedom or free will and determinism and indeterminism, realism as applied to history and some other things, and the amazing essay, The Bucket and the Searchlight, about how knowledge is created. And there's more. Anyways, among all of that is this short essay, The Aim of Science, that I'm going to read through today. That essay is incorporated then into an entire book of approximately the same name. That book is Realism and the Aim of Science, which is a 400-something page tome. But the essay itself, The Aim of Science, was published in 1956, so as far as I know it's out of copyright. But I thought it very useful to go through as it's brief, and I was reading it again recently because so much can be learnt directly from it. And so much more can be learned by comparing the essay in its original form to the improvements made since by David Deutsch. And as much can be learned again by comparing this vision of what science is in terms of the Popperian Deutsch view about science with what everyone else thinks science is about today. People talk about science so much today, about being confident in science, about following the science and so on and so forth. So reminding ourselves of, in fact, what our best understanding of science is should help us anytime someone says that we need to follow the science, let's say. And what you will see almost immediately when I begin reading is that Popper says the aim of science, that framing, could rightly be seen to be misleading. So with all of that in mind, let's begin some reading. As I say, the essay is there on my website right now. You can find a clean PDF copy of it and my comments as well, which amount to my notes for this podcast. But of course, what you'll be missing there, as you will be in the audio-only version of this, is the video with some hopefully interesting images to accompany my reading. Anyway, let's begin. The aim of science. And Popper writes, "To speak of the aim of scientific activity may perhaps sound a little naive, for clearly different scientists have different aims, and science itself, whatever that may mean, has no aims. I admit all this, and yet it seems that when we speak of science, we do feel, more or less clearly, that there is something characteristic of scientific activity. And since scientific activity looks pretty much like a rational activity, and since a rational activity must have some aim, the attempt to describe the aim of science may not be entirely futile." End quote. Okay, so already he has the caveat, and this is due to the imprecision of language. Don't take too literally the claim that science has an aim, as in it is aiming for a particular thing. You know, take particle physics, for example. Is the aim to just find ever smaller particles? You might think so, but that would be to presume the conclusion. That would presume too much. It assumes that you can go on forever, finding ever smaller particles. Or maybe you just think the aim should be to find the smallest particle. Maybe the particle's inside the electron, so to speak. Similar error. Who says there must be such a thing? The aim of science in modern speak is just to solve scientific problems. That might be a little circular, it seems, but it's not entirely vacuous. You have to identify the problem first, which can also be a part of science. Popper goes on, quote, "I suggest that it is the aim of science to find satisfactory explanations of whatever strikes us as being in need of explanation." End quote. Well, there we go. Isn't that nice? Right there up front. Anyone who is listening now to me will know that I, like many Popperians, complain that people who critique Popper almost never read Popper directly, or at least don't read enough of him. Or perhaps read but do not understand him. And here's a perfect example. There it is in black and white. When prominent scientists and science communicators or philosophers, or let's throw podcasters into that mix, when they say, well, Popper was naive, Popper thought that science was just about falsifiable ideas or claims or theories or whatever you like, we can see here now that that is a complete misconception. Popper knew that science was about explaining the world, about explanations, and indeed of anything in the physical world that you like. But we do see here at this point that he's invoked a particular term, satisfactory. Now that's not quite what David Deutsch says. Deutsch talks about good explanations, and that is broader than just science. Science is, of course, that domain of inquiry that is about the physical world, and we can include there the chemical and geological and biological and astronomical and so on world as aspects of that physical world. So science is about good explanations, which are hard to vary explanations, of the world, the physical world. Popper says satisfactory. And he'll say something more about that in just a moment. But as we were about to read, he gets into some jargon. This is, again, a product of his time. And I've always found what he's about to say, in the way that he says it, a little bit too jargony, and as many people listening will know, I'm not a fan of jargon. These aren't quite neologisms at all. He certainly didn't invent the word, but again, they're a product of his time, and it's a philosopher talking to other philosophers. I think we can tend to do without them for the most part, but for the moment, I'll explain what they are, read through what Popper is saying, and then we can see that really you can kind of dispense with them. So let's go on. Popper writes, quote, "By an explanation, or a causal explanation, is meant a set of statements by which one describes the state of affairs to be explained, the explicandum, while the others, the explanatory statements, form the explanation in the narrower sense of the word, the explicans of the explicandum." End quote. Okay, so as you can see, it's a little confusing if you're not a professional philosopher. Already we've got this explicandum and explicans distinction. Explanation is fine. No one's got a problem with explanation. That's the thing we're trying to explain. But explicandum? Well, as he's saying there, explicandum just means the thing in need of an explanation. So at night you go outside and you see small lights in the sky. That's your explicandum. You don't know what they are yet, perhaps. You might be a young child. You might have been living 10,000 years ago. You might have been growing up in a cave in Afghanistan for the last 20 years. Whatever. Those lights in the sky are the things in need of an explanation. I'd rather say, well, that's your problem. Or that's the question. The lights are real. You're not just imagining them. They're not hallucinations. But what are they? Well, you might say, they are holes in a vast black glass dome that encircles the entire planet, and beyond this there is a region of white light, so through those holes comes that light. Now that's an explanation. It's not a good explanation. It's not testable for all practical purposes either, so far as I know, if you really believe that, unless you send a rocket up there, but then you've got other issues about how the rocket works in a context where you believe in the celestial sphere. But whatever the case, you've got a glass dome over the earth. That's the claim that's being made. That's the explicans, a part of the explanation, an assertion about the world. There are holes in that dome, another part of the explanation, another explicans. I find this all very clunky. But Popper is precise, of course. The real explanation is that those lights are stars. The stars are bright. The stars are also far off, so they appear dim. They are bright because they're hot. They are hot because they're vast in mass. With huge mass comes high gravity. With high gravity comes high pressure at the core of any such thing, and if the pressure is high enough because the mass is high enough, fusion can happen. Fusion happens because, well, I won't go on, but you can see here more and more explicans, in Popper's terminology, are going into the overall explanation. The explicandum is lights in the sky. An explican of this is those lights are stars. Stars can then be seen as a new explicandum, another thing in need of explanation. And the explicans of that is stars are big spheres of plasma undergoing fusion. And the explicandum then becomes fusion, and so it goes. And the conjunction of these, in a sense, makes up the explanation. Let's go back to Popper. And he wrote, quote, "We may take it as a rule that the explicandum is more or less well known to be true, or assumed to be so known. For there is little point in asking for an explanation of a state of affairs which may turn out to be entirely imaginary. Flying saucers may represent such a case. The explanation needed may not be of flying saucers, but of reports of flying saucers. Yet should flying saucers exist, then no further explanation of the reports would be required. The explicans, on the other hand, which is the object of our search, will, as a rule, not be known. It will have to be discovered. Thus, scientific explanation, whenever it is a discovery, will be the explanation of the known by the unknown." End quote. Okay, so to unpack that there, especially where he says the explicandum is more or less well known to be true, I think that by true he really means real. It exists. It's out there in the world. It's not entirely part of your imagination. And by the way, it's interesting that he uses flying saucers here. If you want the David Deutsch take on such things, see my podcast episode 72, titled David Deutsch Comments on a Recent UFO Sighting, a question for David number 3. So what Popper is saying there, though, in the paragraph I just read, is that the problem with flying saucers typically is the reports. What are the reports about? It's not flying saucers as such, it's reports of them. Well, it may be the case that there are flying saucers, actual flying saucers, and we should be careful what we mean by that. What we mean are alien spacecraft travelling here to Earth from light years away, not people throwing plates and dishes into the air and others wondering, what was that? Not that kind of flying saucer. But the thing is, we have reports of flying saucers even through to today, but that's it. We have to explain the reports. The explicandum is the reports, not the sources. The reports of flying saucers almost always turn out to be something that's not a flying saucer, like the planet Venus, or a hallucination, or a shooting star, or name your mundane explanation. The flying saucer is a label for a problem, not the name of a solution. If an actual saucer crashed and it was clearly not of this world, then we have a new explicandum. Then it's not merely a report, it's an actual flying saucer. The problem then demands an explanation in terms of, where the heck did this come from? How and who and so on? Was it Venus or Mars or an Andromeda strain, Klingons, etc.? And let me just go back to the very final sentence that I read there from that paragraph. Popper said, "Thus, scientific explanation, whenever it is a discovery, will be the explanation of the known by the unknown." And isn't that nice? It's very reminiscent of something that David Deutsch says. David doesn't say the known by the unknown, he improves it. He speaks of the seen in terms of the unseen. And that is more precise. That is an improvement. And the reason I say that is because saying that the known is explained by the unknown implies that part of the explanation is unknown. But this is not quite right, or at least the emphasis is a little bit murky. It might not have a complete explanation, of course. Explanations are not fully self-contained. Some parts remain unexplained, and indeed, Popper's about to talk about that. We cannot have complete explanations. But this known in terms of unknown thing actually arises from a discussion Popper is having in this paper about Bishop Berkeley and Mark, and it all gets a bit esoteric. And that's coming from me doing a podcast on an obscure essay by Popper. But anyways, a note in Popper's text here at this point in his essay leads one on a bit of a goose chase to another book of his, Conjectures and Refutations. And in that book, if we look up what he's talking about when he says the known is explained in terms of the unknown, well, I'll just quote from Conjectures and Refutations, the bit where he's referring us to. Popper writes, quote, "So we can now admit, without becoming essentialist, that in science we always try to explain the known by the unknown, the observed and observable by the unobserved and perhaps unobservable. At the same time, we can now admit, without becoming instrumentalist, what Berkeley has said of the nature of hypothesis in the following passage, which shows both the weakness of his analysis, its failure to realize the conjectural character of all science, including what he calls laws of nature, and also its strength, its admirable understanding of the logical structure of hypothetical explanation." End quote. So what I would say is we can see right there, he actually does say the observed by the unobserved. We can explain the observed in terms of the unobserved, which is far closer to the mark. I prefer David's, which is simpler language, the seen in terms of the unseen. Lights in the sky at night, you can see them, they're the seen. You explain them in terms of fusion reactions in the core of those stars hundreds of light years away. Unseen, and indeed, in principle, unseeable, given how observation requires an observer, and observers, so far as we know, cannot exist in the core of stars. But that's a side issue. We can see here how David has clarified Popper. Let's go back to the original essay. Popper writes, quote, "The explicans, in order to be satisfactory, satisfactoriness may be a matter of degree, must fulfill a number of conditions. First, it must logically entail the explicandum. Secondly, the explicans ought to be true, although it will not in general be known to be true. In any case, it must not be known to be false, even after the most critical examination. If it is not known to be true, as will usually be the case, there must be independent evidence in its favour. In other words, it must be independently testable, and we shall regard it as more satisfactory the greater the severity of the independent tests it has survived." End quote. So Popper was heavily influenced by a philosopher, mathematician called Alfred Tarski. Indeed, his book Objective Knowledge is dedicated to Tarski, and Tarski had a nice view of truth, which was about correspondence. A thing is true if it corresponds to something in reality. But anyway, Popper used the word true pretty liberally, more liberally than I do. And the reason I'm not very liberal with it is that, following David, I would say that truth, it definitely exists, I'm not a relativist, truth is a property of propositions. So we can never be in a position to say that some part of an explanation, the explicans, can ever be known to be true. Known means something like have an explanation of, in many cases anyway. And given no explanation is final, as I say, Popper will come to shortly, known to be true is a paradox of a kind if you take Popper seriously, because true is final. If a thing is known to be true, then what we are saying is it could be false, that it could not possibly be false. It's one of those cases where I'd love to be able to speak to Popper exactly about that and to see what he meant, but we'll pass over this. The point in this paragraph is more about the fact that any given part of your explanation should itself be testable in science. That's the key point. I would not say evidence in its favour, as he said. I think that has a bit of an odour of justificationism about it. The idea that evidence can accumulate and thereby make a theory more likely to be true or actually true or something like that. Again, I think Popper is actually trying to win over his opponents with phrases like this at times. And I think that's right to do if you want to have any readers at all left, if you're absolutely tearing apart of some hitherto pre-existing fabric of an entire discipline, like philosophy of science and epistemology, which is what Popper has done throughout his work. So he has to try and play the game of attracting people to his work before undermining all of their most cherished beliefs. So I understand the motivation of wanting to speak in terms of people who completely disagree with you. He's playing a difficult game. It must have been so difficult at times to be Popper, to go into these discussions, having to operate in two different worlds of language. The one where he's trying to better understand what these words mean, and everyone else who is cleaving closely to what, for example, the dictionary says. But anyways, in that paragraph I just read, he said the actual important thing there. The various parts of an explanation should be testable. Indeed, the severity, as he says, of the testability is important. So, highly precise, in other words. If I make a testable claim like, this ball will fall to the ground if I drop it, that's one thing. If I say it will fall at 9.8 meters per second squared, that's something else. And if I say it will fall initially at 9.8 meters per second squared, and then 9.801 meters per second squared, and then 9.805 meters per second squared, and so on, increasing to a maximum of 9.81 meters per second squared just before it hits the ground, I'm getting even more precise, more risky, so to speak. By the way, Popper will actually use an example like this shortly. I'll explain why that happens too when I get there. But for now, I'm skipping a paragraph that he's got there and going instead to an example he uses to illustrate the satisfactory versus unsatisfactory distinction that he has. We will see here echoes of the beginning of infinity. So Popper writes, quote, "Consider the following dialogue. Why is the sea so rough today? Because Neptune is very angry. By what evidence can you support your statement that Neptune is very angry? Oh, don't you see how very rough the sea is? And is it not always rough when Neptune is angry?" This explanation is found unsatisfactory because, just as in the case of a fully circular explanation, the only evidence for the explicans is the explicandum itself. The feeling that this kind of almost circular or ad hoc explanation is highly unsatisfactory and the corresponding requirement that explanations of this kind should be avoided are, I believe, among the main motive forces of the development of science. Dissatisfaction is among the first fruits of the critical or rational approach, end quote. So that's lovely. He's getting to the idea there that science is a problem-solving exercise, and when you have this feeling of dissatisfaction, something's not quite right, it's there that you can make progress. And in terms of that example, what he's saying is, so the thing in that example that is in need of the explanation is, why is the sea so rough? Why, we ask, is it so very rough today? Well, if we say, because Neptune is so very angry, and it's always rough when Neptune is angry, we've gotten nowhere. The bit of the explanation that is invoked, the sea is angry when Neptune is rough, is not testable, because we will just say when it's more rough, Neptune is more angry, and when it's less rough, Neptune is less angry. This is what happens when people try to support a theory with evidence. Each day, no matter the state of the sea, that counts as evidence supporting the claim the anger of Neptune makes the sea rough. But that itself is never testable, which is what we want. In modern language, the way David explains this, we say that the Neptune theory is easy to vary. This takes the idea of satisfactory versus unsatisfactory explanations that Popper devised a big step forward. The hard-to-vary criterion for a good explanation is more precise than what Popper offered. Neptune, after all, could be swapped out for Poseidon, or Ulmo, he's from Lord of the Rings, or Aquaman, take your pick. It's easy to vary, but the idea that the action of the sun, heating the oceans, creating air currents that can cause high pressure in one place and low pressure in another, and this causes wind, and the wind causes waves, and that makes the sea rough, well, we can't just go swapping out the sun for something else in the sky. We can't go swapping high pressure for low pressure, and wind for anything else. But let's continue. Popper wrote, quote, "In order that the explicans should not be ad hoc, it must be rich in content. It must have a variety of testable consequences, and among them, especially, testable consequences which are different from the explicandum." End quote. Okay, so yes, the explicans, the parts of the explanation, actually invoke the existence of things that previously were unseen or unobserved. Those things then form a part of the testable content of the explanation. And this is why empiricism is false, a point which we have made here in this podcast many times. The explanation consists of a bunch of unseen things, but we can test our explanation of those unseen things because those unseen things give rise to the things we do see, and typically the only known explanation of the things we do see and which we can measure and experiment on and so on is the unseen things. To deny the unseen is to deny reality. But the only unseen things we say exist are the ones that actually appear in our best explanations, not just any unseen things. This makes the difference between unseen Roman gods and unseen fusion reactions in distant stars. Now, I'm going to skip another large part of the essay, and Popper goes on to speak about the case of universal laws. He writes, quote, "Only if we require that explanations shall make use of universal statements or laws of nature, supplemented by initial conditions, can we make progress towards realizing the idea of independent or non-ad hoc explanations. For universal laws of nature may be statements with a rich content so that they may be independently tested everywhere and at all times. Thus, if they are used as explanations, they may not be ad hoc, because they may allow us to interpret the explicandum as an instance of a reproducible effect. All this is only true, however, if we confine ourselves to universal laws, which are testable, that is to say, falsifiable." End quote. Now here, ad hoc means something like made up for a specific purpose rather than being general, so general as to be universal in fact. And the concept of universal means to apply everywhere. What we're after are universal explanations of various things, universal ways in which knowledge is created, the universal principles of wealth creation, universal laws of chemistry, of physics, of the drift of continents, the formation of rocks and so on. But broadly speaking, physics, physical laws. They don't just apply in the laboratory where the physicist is working. They apply everywhere in the universe and at all times. Popper goes on to say, quote, "The question, what kind of explanation may be satisfactory, leads to the reply, an explanation in terms of testable and falsifiable universal laws and initial conditions. And an explanation of this kind will be the more satisfactory, the more highly testable these laws are, and the better they have been tested. This applies also to the initial conditions." End quote. Now to me, testable and falsifiable are the same thing. But maybe he is saying that for emphasis. As to the initial conditions thing, well, as we know, David Deutsch has invented constructor theory, which goes deeper than this conception of physics. Perhaps it's better in the future not to specify what forms the laws must be or what kind of explanations can be developed. Better to just say what kind of explanation may be said to be good. Well, in science, testable is part of it, but a good explanation is hard to vary. As to whether it needs to be about laws and initial conditions, well, we know it does not. It can be about what is possible and impossible. Can there be more still? I imagine so, but there is no reason to close off the possibility of inventing still more modes of explanation. Perhaps providence or intentions and so on can actually be brought into physics one day. Who knows? I guess Popper did not really imagine that physics might begin to make its first steps into epistemology, tentatively. But it is happening. Let's keep going. Popper writes, quote, "In this way, the conjecture that it is the aim of science to find satisfactory explanations leads us further to the idea of improving the degree of satisfactoriness of the explanations by improving their degree of testability. That is to say, by proceeding to better testable theories, which means proceeding to theories of ever richer content, of higher degrees of universality and of higher degrees of precision. This, no doubt, is fully in keeping with the actual practice of the theoretical sciences. We may arrive at fundamentally the same result also in another way. If it is the aim of science to explain, then it will also be its aim to explain what so far has been accepted as an explicans, for example, a law of nature. Thus, the task of science constantly renews itself. We may go on forever, proceeding to explanations of a higher and higher level of universality, unless indeed we were to arrive at an ultimate explanation. That is to say, an explanation which is neither capable of any further explanation nor in need of it." End quote. So, ultimate, or final, or an end of infinity, and an end of science, and an end of progress. Now, we know what David thinks about all this, and what we should all think about all this. It is possibly a prime motivation for his book, The Beginning of Infinity. But what does Popper have to say about it? Well, let's read on. Quote, he writes, "But what are ultimate explanations? The doctrine, which I have called essentialism, amounts to the view that science must seek ultimate explanations in terms of essences. If we can explain the behaviour of a thing in terms of its essence, of its essential properties, then no further question can be raised and none need be raised, except perhaps the theological question of the creator of the essences." End quote. And then Popper goes into a long discussion about Descartes and Newton. Descartes thought one could get to final answers, but Newton didn't seem to. The example Popper uses is in Newton's willingness to admit that although he did indeed have a law of gravity and made more progress on the nature of gravity than anyone else before him, he nevertheless never said, and said he could not, say what actually gravity really was. What actually caused the force of gravity? He did not know, and he said as much. He accepted he had made some progress, but not found that answer, which is rather odd given how so many physicists who came after him did indeed make noises about how Newton was almost lucky because of the fact he found the once and for all final theory of gravity, when Newton himself seemed to think he didn't, or didn't quite. There was more to do. There's always more to do. Popper actually goes on to quote Newton in the Principia, and Newton wrote, quote, "So far I have explained the phenomena by the force of gravity, but I have not yet ascertained the cause of gravity itself, and I do not arbitrarily or ad hoc invent hypotheses." End quote of Newton. Now, it might be said that Popper is kind of criticising Newton for apparently not even trying. So for Newton, well, Newton thinks he is deriving rather than conjecturing, of course. He is reading from the book of nature, and that book does not tell him what the cause of gravity is. At least this is one way of trying to understand what Popper eventually goes on to say about Newton. Whatever the case, essentialism is the misconception that in a physical thing, like gravity, or an electron, or even a bacterium, or a person, there is no such final thing to be found which, when you've found it, its essence, so to speak, then all the explaining of that thing has been done. This never happens. Like gravity, we find that it obeys the inverse square law. Then we find, well, not exactly. And then we find it's the curvature of space-time. But what is space-time made of, if that even makes any sense? And is it truly continuously divisible? These are open questions. With gravity, even now, must the gravitational constant truly be constant? A person is a universal explainer, but is that the essence of a person? I wouldn't think so. It's more a precise statement of the problem that could not even have been articulated before. Anyways, Popper goes on, quote, "I do not believe in the essentialist doctrine of ultimate explanation. In the past, critics of this doctrine have been, as a rule, instrumentalists. They interpreted scientific theories as nothing but instruments for prediction, without any explanatory power. I do not agree with them either, but there is a third possibility, a third view as I have called it. It has been well described as a modified essentialism, with emphasis on the word modified," end quote. Well, there we have classic Popper, of course. He always finds the third way. He rejects the false dichotomy. Just because you've got X and Y before you, and X and Y are all you know, and form your spectrum of choices, does not mean they are the only choices you in fact have. You can actually use your mind and create something new. He goes on to say, quote, "This third view, which I uphold, modifies essentialism in a radical manner. First of all, I reject the idea of an ultimate explanation. I maintain that every explanation may be further explained by a theory or conjecture of a higher degree of universality. There can be no explanation which is not in need of a further explanation, for none can be a self-explanatory description of an essence, such as an essentialist definition of a body, as Descartes suggested. Secondly, I reject all what is questions asking for what a thing is, what is its essence or its true nature. For we must give up on the view, characteristic of essentialism, that in every single thing there is an essence, an inherent nature or principle such as the spirit of wine in wine, which necessarily causes it to be what it is, and thus to act as it does. This animistic view explains nothing, but it has led to essentialists, like Newton, to shun relational properties such as gravity, and to believe on the grounds felt to be a priori valid that a satisfactory explanation must be in terms of inherent properties, as opposed to relational properties." End quote. So the first thing he says is that All explanations will eventually need a further explanation. And then the second thing he says is that there are no essences, no place in science where the buck stops here, so to speak, where you've found the ultimate essence. He goes on to write, quote, "The third and last modification of essentialism is this: we must give up on the view, closely connected with animism and characteristic of Aristotle as opposed to Plato, that it is the essential properties inherent in each individual or singular thing which may be appealed to as the explanation of this thing's behaviour. For this view completely fails to throw any light whatever on the question why different individual things should behave in like manner. If it is said because their essences are alike, the new question arises: why should there not be as many different essences as there are different things?" End quote. So all of this is the problem of essentialism. Okay, so people at the time were not fixated on trying to find universal laws that applied everywhere at all times, but rather these essences, what the final ultimate nature of a thing happened to be. And Popper thinks all of this is misconceived. Instead, don't look for the essence of something. Look instead in science for more and more universal laws. And so after skipping a few paragraphs that I'm doing now, he then goes on to say, quote, "By choosing explanations in terms of universal laws of nature, we offer a solution to precisely this last Platonic problem. For we conceive all individual things and all singular facts to be subject to these laws, the laws, which in their turn are in need of further explanation, thus explain regularities or similarities of individual things or singular facts or events. And these laws are not inherent in the singular things, nor are they Platonic ideals outside the world. Laws of nature are conceived, rather, conjectural descriptions of the structural properties of nature, of our world itself." End quote. Now, here I would say there's just a little ambiguity. There are the laws of nature. Notice the definite article there, the, and make it capitalized, the laws. Now, those laws, the laws of nature, exist independently of what we think about them, what we know about them, just like particles do, or cats do, or crayons do. But our understanding of the laws of nature, they're conceived. They are conjectural. Popper understood this, of course, I would say, and it's simply because language is imprecise at times. But sometimes we have to be very careful, very much so in epistemology, to distinguish between the thing itself and our understanding of the thing. They're clearly not the same. And the laws of nature are like this. There's our understanding of the laws of nature. There's the standard model of particle physics. But the standard model of particle physics isn't necessarily the final word. In fact, we would say it's not the final word. It can't be the final word. There's open questions there. And so, does the standard model of particle physics constitute the laws of particle physics? Well, it's our understanding of the laws, but we'll never get to the final understanding of the laws of physics. In fact, Popper kind of gets to this in the next paragraph where he says, quote, "Here then is the similarity between my own view, the third view, and essentialism. Although I do not think that we can ever describe, by our universal laws, an ultimate essence of the world, I do not doubt that we may seek to probe deeper and deeper into the structure of our world, or, as we might say, into properties of the world that are more and more essential, or of greater and greater depth." End quote. So I think it's possibly better if he just stuck with greater depth. He didn't have to concede more and more essential. More fundamental is okay. That seems to be better. But more essential? That might be misleading. We can reject essences altogether and therefore not worry about being more or less essential because the essence doesn't exist even to begin with. David Deutsch likes to point out that he works on the foundations of physics, but he's not a foundationalist. When one says they are working on the foundations in physics, what they mean is they are working on the deepest theories known and trying to go still deeper, the most fundamental, what other people call the foundations, the deepest known. But this does not imply they are the literal foundations. Actual foundations are, in a sense, where a structure stops. Or are they? Because that too is ambiguous. If the foundations of physics are like the foundations of a building, then of course there is something deeper there, something that hitherto was not regarded as being a necessary part of the structure. In physics, something that is outside of physics, like constructor theory, or like computation, Or in the case of an actual building, are the foundations the bricks and steel columns on which the ground floor sits? Or is it the existence of a basement? Or the concrete slab on which the basement rests? Or is it necessarily the case that you need to have a bedrock beneath all this, which, if it was less stable than it was or didn't exist, it wouldn't be a solid foundation? Or is it what is below even the bedrock, deeper geological structures not normally thought of as being a necessary part of a building at all? Well, it depends on how far you want to push the analogy. But we can speak about the fundamentals, the deepest known theories that explain the most, encompass the most, and have the greatest reach. Now Popper really gets into the swing of things, and I find the following passages like this brilliant because, remember, it really is unprecedented. He's the first to come up with this, and he says, quote, "Every time we proceed to explain some conjectural law or theory by a new conjectural theory of a higher degree of universality, we are discovering more about the world, trying to penetrate deeper into its secrets. And every time we succeed in falsifying a theory of this kind, we make a new important discovery. For these falsifications are most important. They teach us the unexpected, and they reassure us that, although our theories are made by ourselves, although they are our own inventions, they are nonetheless genuine assertions about the world, for they can clash with something we never made." End quote. That's brilliant. That's perfect. And that's eloquent. And I think it's important to keep in mind that, again, he was the first to say things like this. And it said so well there. So although, and again, let me just read those words again. Our falsifications, our theories, they teach us the unexpected. And they reassure us that although our theories are made by ourselves, although they are our own inventions, they are nonetheless genuine assertions about the world, for they can clash with something we never made. So we have this idea of creativity and criticism. It's just beautiful the way that he expresses it there. That some of this knowledge is indeed a pure product to some extent of our minds, but it encounters reality. It clashes, as he says there. And that clash is with something we did not make. The thing we made encountering the thing we did not make. And of course, by the time he wrote this, he's already been engaged for many years in long discussions about all of this. So he has refined his position, but it still reads as clearly as anyone writing today along similar lines could possibly manage. Popper goes on to write extensively about the concept of depth. Now, I'll read some of it, but mainly I'll just summarize. In the next few paragraphs, he says that depth has something to do with simplicity, and this is something like coherence or brevity, and something to do with richness of content. So this is what depth is. The depth of a theory has something to do with simplicity and richness. And this kind of gets the idea that David refines called reach. Reach means that the content of the explanation has an effect on far-reaching, hence reach, on far-reaching subjects, on distant subjects. So what happens in physics absolutely has consequences for chemistry, but also aviation, computing, etc. Physics has maximal reach. Mathematics sometimes has reach. Sometimes a particular theorem has nothing to do with the physical world. Philosophy likewise. Sometimes it has reach, like in epistemology. Sometimes it's a little bit more parochial. Anyways, what Popper says about depth, and it being about simplicity and richness, is that he cannot define or restrict what he means here. He is appealing to intuition, which is quite right. As David says, no language can be perfectly precise, but we can still have a reasonable understanding. We can get an idea of what depth is, or degrees of depth, by considering an actual example. And Popper turns to the history of physics for this, so let's go down that road with him for a moment. And he writes, quote, "It is well known that Newton's dynamics achieved a unification of Galileo's terrestrial and Kepler's celestial physics. It is often said that Newton's dynamics can be induced from Galileo's and Kepler's laws, and it has even been asserted that it can be strictly deduced from them. But this is not so. From a logical point of view, Newton's theory, strictly speaking, contradicts both Galileo's and Kepler's, although these latter theories can of course be obtained as approximations once we have Newton's theory to work with. For this reason, it is impossible to derive Newton's theory from either Galileo's or Kepler's or both. whether by deduction or induction, for neither a deductive nor an inductive inference can ever proceed from consistent premises to a conclusion that formally contradicts the premises from which we started. I regard this as a very strong argument against induction." End quote. So what he's saying here is theories are grand creations. They are grand conjectures. They are creative acts. They're invented. And in a sense, this is kind of coming at that age-old distinction between is it discovered or is it invented? Well, the invention is the theory. The discovery is the encounter with reality. In either case, it's not a deduction from things known earlier or from things induced either, as induction would have it. It's creative. It is conjectured. Okay, so now I'm going to read a couple of paragraphs and stop along the way and just make a few comments rather than flagging that too much. Popper writes, quote, "I shall now briefly indicate the contradictions between Newton's theory and those of his predecessors. Galileo asserts that a thrown stone or a projectile moves in a parabola, except in the case of a free vertical fall when it moves with constant acceleration in a straight line. We neglect air resistance throughout this discussion. From the point of view of Newton's theory, these assertions are both false for two distinct reasons." Just pausing there in my little reflection on this. Yes, so if you learn high school, undergraduate physics at a low enough level, and you try and predict the path, you try and do the mathematics, the physics, in order to predict where a cannonball will land, let's say, what the range of a cannonball is, what the height of a cannonball is, and so on. You presume Galileo-type theory. You presume the projectile moves in a parabola. And you can get relatively precise results for this. But strictly speaking, we also learn that it is false. It's false for a number of reasons, not least of which is, of course, when you're firing some kind of object like a cannonball, what's actually going on is the thing is trying to get into orbit. If you were to fire the thing fast enough, it would indeed enter an orbit. And an orbit is absolutely not a parabola. It is elliptical. It's an ellipse. So this is to do with a part of mathematics called conic sections. Don't need to go into that. The fact is that Galileo asserts projectiles follow parabolic paths. Newton's theory says that they follow elliptical paths. And Newton has an explanation as to why it can't be or is not a parabola, which we're going to come to. Okay, so Popper has just said there that Galileo asserts that a stone thrown or a projectile moves in a parabola, except in the case of free vertical fall, when it moves with constant acceleration in a straight line. And then he goes on to say, quote, "From the point of view of Newton's theory, these assertions are both false for two distinct reasons. The first is false because the path of a long-range projectile, such as an intercontinental missile, thrown in an upward or horizontal direction, will be not even approximately parabolic, but elliptic." I'll just pause there. I don't think a missile is well, depends on what he means by missile. These days, of course, what we mean by missile is a rocket-propelled thing. And a rocket-propelled thing is actually not a projectile at all. It falls under a thing called ballistics because it's got a rocket behind it and so it's being propelled. And especially an intercontinental missile. An intercontinental missile is not just a projectile either. It can travel in any direction you like because all you need to do is to steer the thing using the rocket. And so you could, in fact, have it going straight up into the air. So the dispute is not really about something that's got an engine on it. And again, we could ask Karl Popper about this, but I think really what we want to talk about is a long-range projectile, something that has been fired a long, long way. Anyway, that little quibble aside, let's keep going. Popper writes, "It becomes approximately a parabola only if the total distance of the flight of the projectile is negligible compared with the radius of the Earth. This point was made by Newton himself in his Principia, as well as in his popularized version, The System of the World, where he illustrates it with the help of a figure reproduced on this page. Newton's figure illustrates his statement that if the velocity of the projectile increases, and with it the distance of its flight, it will, at last, exceeding the limits of the Earth, pass into space without touching it." Just pausing there, my reflection. Well, you can see the picture if you're watching the video version of this, but if you're merely listening on audio to this, let me describe what Newton's idea was. His idea was you take a cannon of some kind, you stick it on top of a mountain, you fire the cannon, and of course the cannonball follows the characteristic curve that a cannonball will follow, or that any projectile will follow down towards the ground. Now, what if you fire the cannon still faster? Well, it goes further. What if you fire it faster than that? Well, you can imagine a situation where you fire it so fast with such great velocity that it travels all the way around to the other side of the world. What if you fired it with such a velocity that it travelled around to the other side of the world and kept on going all the way back to where it began? Well, then you would have this thing called an orbit, and an orbit is absolutely not a parabola. And nor is any partial orbit. All of these things follow a part of a conic section called an ellipse. Okay, it's an elliptical orbit. Indeed, Popper says, quote, "Thus a projectile on Earth moves along an ellipse rather than a parabola. Of course, for sufficiently short throws, a parabola will be an excellent approximation. But the parabolic track is not strictly deducible from Newton's theory unless we add to the latter a factually false initial condition, and one which, incidentally, is unrealizable in Newton's theory since it leads to absurd consequences to the effect that the radius of the Earth is infinite. If we do not admit this assumption, even though it is known to be false, then we always get an ellipse, in contradiction to Galileo's law, according to which we should obtain a parabola." End quote. Now, what on earth is Popper emphasizing this for? Well, he's emphasizing it again because of this idea, this misconception, that somehow there, nascent, hidden somehow, lurking in the theory of Galileo is the theory of Newton. That somehow you can deduce at least part of Newton from Galileo. And the conjunction of Galileo and Kepler, perhaps, you can definitely get Newton out of that. So that misconception went. And so many people still kind of believe to today. They have this idea in their minds. This is the way sometimes that it's taught, that you're just deriving more and more mathematics from this more primitive sort of mathematics, as if these earlier physical theories, these simpler physical theories, act as axioms. And doing the right mathematics, you end up with Newton's theory. But this is wrong, as Popper says there. They strictly contradict each other. They are, each of them, creative conjectures. Okay, let's keep going. Popper goes on to say, quote, "A precisely analogous logical situation arises in connection with the second part of Galileo's law, which asserts the existence of an acceleration constant. From the point of view of Newton's theory, the acceleration of free-falling bodies is never constant. It always increases during the fall, owing to the fact that the body approaches nearer and nearer to the centre of attraction. This effect is very considerable if the body falls from a great height, although, of course, negligible if the height is negligible as compared with the radius of the Earth. In this case, we can obtain Galileo's theory from Newton's if we again introduce the false assumption that the radius of the Earth is infinite, or the height of the fall zero." Pausing there, my reflection, end quote for that bit. Yes, so this is what I hinted at earlier on, okay? You're making precise predictions about things. Under something like Galileo's physics, you can just assume, and physics students around the world understand this perfectly well, you just make the assumption that the acceleration due to gravity near to the Earth's surface is 9.81 meters per second squared. But this makes no sense at all if you're trying to figure out exactly how fast a dropped object from, let's say, 50 kilometers up will be traveling by the time it reaches the ground. You can't assume 9.81 meters per second squared is the acceleration of that object in freefall. And the reason that you can't, even ignoring air resistance, the reason you can't is because the acceleration due to gravity, or the gravitational potential, at that height of 50 kilometers, if you like, is certainly not 9.81 meters per second. And if you're interested in geophysics, it actually becomes really, really important. This difference in the value of the acceleration due to gravity at different places around the Earth. It's not a constant. But in Galileo's theory, it is a constant. So how could you possibly derive a theory like Newton's, which is a theory of non-constant acceleration when bodies are dropped in free fall, from a theory which insists on constant acceleration for bodies in free fall? Well, you can't, of course. You can't square that circle. One cannot be derived from the other. Popper goes on to say, quote, The contradictions which I have pointed out are far from negligible for long-distance missiles. To these we may apply Newton's theory, with corrections for air resistance of course, but not Galileo's. The latter leads simply to false results, as can easily be shown with the help of Newton's theory." End quote. And we can also port this whole discussion to the modern day, where we talk about how you can't merely use Newton's theory of gravity in order to do all sorts of interesting predictions at a really precise level, like a GPS system. If you want highly precise GPS predictions of your position on the Earth, Newton's theory won't do it. You cannot derive general relativity from Newton's theory. General relativity is not merely a numerical correction to Newton's theory. It's an entirely different way of envisaging what space-time gravity is. It's just that we say that if you assume certain things strictly false in general relativity, then you can get to Newton's theory of gravity. Okay, Newton's theory of gravity is a low velocity, low mass approximation to sum of relativity. Anyways, Popper then goes on to write about Kepler and compares Kepler to Newton in terms of planetary motion. And the same point roughly is made. Newton's theory succeeds in a way Kepler's fails. He uses the example of Kepler's law for how a central body is orbited by smaller bodies. And in Kepler's view, there's this thing, the period-radius relationship, which is basically that the cube of the radius of the orbit divided by the square of the period of the orbit. It's a constant. It's a constant in the solar system for all planets. It doesn't matter what the planet is, whether it's Mercury or whether it's Jupiter. We just assume that there is this constant ratio, but it's only approximately constant. And approximately constant is not constant. And approximately true is not true. It's false. Jupiter's mass, the fact is, the mass of all the planets, affects how fast they orbit the sun, okay? And Jupiter happens to have a large mass, so its mass does have a substantial effect on how fast it orbits the sun. But not according to Kepler's theory. Kepler's theory just assumes all the planets are the same. And that difference is measurable. It's a deviation from Kepler's theory. Kepler's law of periods is measurable. You can reduce Newton's prediction to Kepler's by assuming that the orbiting planets like Jupiter or Earth, etc., have zero mass. But as Popper says on exactly that point, and I'll quote him, he says, "This is quite a good approximation from the point of view of Newton's theory, but at the same time, putting m equals 0 is not only strictly speaking false, but unrealizable from the point of view of Newton's theory. A body with zero mass would no longer obey Newton's laws of motion. Thus, even if we forget all about the mutual attraction between the planets, Kepler's third law contradicts Newton's theory." End quote. His whole point is there, Popper's whole point, is that Newton's theory cannot possibly be derived from Kepler's or Galileo's or any combination of them. Newton's theory is a conjecture. It is a created explanation that does not logically follow from the knowledge we had before. It was not deduced from Kepler and Galileo. It was not deduced from observation. It was not deduced from anything. It is conjectural knowledge. As Popper goes on to say, quote, "It is important to note that from Galileo's or Kepler's theories, we do not obtain even the slightest hint of how those theories would have to be adjusted, what false premises would have to be adapted, or what conditions stipulated should we try to proceed from these theories to another. And more generally, should we try to proceed from these theories to another and more generally valid ones such as Newton's. Only after we are in possession of Newton's theory can we find out whether, and in what sense, the older theories can said to be approximations to it." End quote. Yes, so only in retrospect do we look back and go, oh, look, from Newton you can say that Kepler and Galileo are approximations. Yes, if you make some assumptions, but the reverse is never true. You cannot begin with Kepler and Galileo and with some minor corrections get to Newton. This is always the case and should be front of mind for any physicist now working at the frontiers. Just incrementally fiddling with some bits of an existing theory will not lead you to the big breakthrough. You need to go to the foundations and rethink them. Popper goes on to say, quote, "We may express this fact briefly by saying that although from the point of view of Newton's theory, Galileo's and Kepler's are excellent approximations to certain special Newtonian results, Newton's theory cannot be said, from the point of view of the other two theories, to be an approximation to their results. All this shows that logic, whether deductive or inductive, cannot possibly make the step from these theories to Newton's dynamics. It is only ingenuity which can make this step. Once it has been made, Galileo's and Kepler's results may be said to corroborate the new theory. Pause there, end quote. Yes, so ingenuity, creativity, invention, imagination, all that sort of stuff, not deduction, not induction or anything else like that. Now, can we give people help on how to be creative? Not really. We just have to allow them to be free until such time as we have a better understanding of how it is that people make creative conjectures. We just have to allow them the freedom and the space to be maximally creative, because they're not going to be deriving stuff from the book of nature or from pre-existing knowledge. As for how Popper ends that bit there, he says, Galileo's and Kepler's results may be said to corroborate the new theory. I've never much liked that way of saying it. We could just say those theories, Galileo's and Kepler's, may be said to be approximations to some extent to that better theory, low mass approximations, or Newton's theory with some substantial but false assumptions, like, for example, the mass of Jupiter makes no difference to planetary orbits. Corroboration just sounds a little bit justificationist, and I think it can mislead people. But again, I think Popper was trying to concede to his peers who objected to him. When he said confirmations are not possible, for example, so he kind of came up with this other word. He didn't come up with the word, but he thought, oh, well, I'll use the word corroboration. So it's like all these theories agree within a particular domain. That's kind of what he's getting at. Galileo's, Kepler's, Newton's will all agree on a certain kind of prediction given a certain number of assumptions. Anyways, Popper goes on to write that Newton's theory is no mere conjunction of the theories that went before. Instead, it can be thought of as a new way of explaining Kepler's results and Galileo's results, but also, as importantly, corrections to them. So this is how to view the system of knowledge here. A deeper theory explains the less deep theories and points out their errors and corrects them. That's what increasing depth does. And he says it really well once again. He says, quote, I suggest that whenever in the empirical sciences a new theory of a higher level of universality successfully explains some older theory by correcting it, then this is a sure sign that the new theory has penetrated deeper than the older ones. The demand that a new theory should contain the old one approximately for appropriate values of the parameters of the new theory may be called, following Bohr, the principle of correspondence, end quote. And then he also says that there is more to depth still, and I recommend reading the original article for more details on this, specifically page 13 of my PDF version of the document. The term depth is kind of like the term explanation in this sense. We can always find new ways of explaining it, or more deeply understanding depth, or explaining more about what explanations are. Anyway, let's read his concluding remarks. We're just about at the end of the article. And congratulations for persevering with me if you have. All right. Popper says, quote, the task of science, which I have suggested is to find satisfactory explanations, can hardly be understood if we are not realists. For a satisfactory explanation is one which is not ad hoc, and this idea, the idea of independent evidence, can hardly be understood without the idea of discovery, of progressing to deeper layers of explanation, without the idea that there is something for us to discover and something to discuss critically. And yet it seems to me that within methodology we do not have to presuppose metaphysical realism, nor can we, I think, derive much help from it except of an intuitive kind. For once we have been told that the aim of science is to explain, and that the most satisfactory explanation will be the one that is most severely testable and most severely tested, we know all that we need to know as methodologists. That the aim is realizable we cannot assert neither with nor without the help of metaphysical realism, which can give us only some kind of intuitive encouragement, some hope, but no assurance of any kind. And although a rational treatment of methodology may be said to depend upon an assumed or conjectured aim of science, it certainly does not depend upon the metaphysical and most likely false assumption that the true structural theory of the world, if any, is discoverable by man or expressible in human language. Just pausing there, my reflection. That's a curious way of framing things. I'm not sure if it's pessimism or not, but he's denying that we can find the final true structure of the world, which I guess is fine. But why one would need to go on to say that it isn't discoverable or expressible in human language? Well, we can't get to the final answer. And if we can't get to the final answer, of course it's not going to be expressible in human language. But if we could get there, why wouldn't it be? Why wouldn't that problem be soluble? I don't know. Anyway, let's keep going. Popper finally writes, last paragraph, quote, "If the picture of the world which modern science draws comes anywhere near to the truth, in other words, if we have anything like scientific knowledge, then the conditions obtaining almost everywhere in the universe make the discovery of structural laws of the kind we are seeking, and thus the attainment of scientific knowledge, almost impossible. For almost all regions of the universe are filled by chaotic radiation, and almost the rest by matter in a similar chaotic state. In spite of this, science has been miraculously successful in proceeding towards what I have suggested should be regarded as its aim. This strange fact cannot, I think, be explained without proving too much. But it can encourage us to pursue that aim, even though we may not get any further encouragement to believe that we can actually attain it, neither from metaphysical realism nor from any other source." End quote, end of the essay. Now, those last few remarks, some of them are a bit odd and might be worthy of additional discussion, but really, I think David Deutsch answers them. Popper, for example, there seems to think that most of the universe would be hostile to knowledge production. Well, absent people, of course, and that would be vacuous. If there's no knowledge creator, no knowledge will be created. But given people, it's clearly false. It doesn't matter how chaotic this so-called radiation is. Why he uses the word chaotic, I don't know. The evidence out there in intergalactic space is there for the taking. And as David Deutsch observes, if you really wanted to, you could learn almost everything in science by building a sufficiently large space station, using the matter in otherwise empty space, because it's not completely empty after all. We could learn about physics and chemistry. It might be a little bit harder to learn about geology unless we travel to a planet. And it'd be really hard to learn about ecosystems on Earth without going all the way back to Earth, as he quipped that the only thing that would be difficult to do is like nature walks or whatever. But we could certainly learn about other aspects of biology. We could learn about evolution by natural selection if it wasn't already known. So this idea of chaotic radiation being some sort of impediment to us creating knowledge out there in the universe, the rest of the universe is hostile. It's only hostile absent people. But people are growing in number, growing in power and knowledge and wealth. And so one day, even those parts of space that Popper is calling chaotic and hostile won't be. Even the Earth, as David Deutsch points out, is itself hostile, and we have managed to eke out a way of creating an open-ended stream of knowledge creation. So this idea of chaotic radiation is not quite right, or at least the emphasis is not right. Popper, unusually, seems to have actually underestimated the power of his own area of expertise, objective, explanatory knowledge, because it is that can make order out of that chaotic radiation, gather it with even modest telescopes, take measurements, and guess at what it all means. Any region of space is almost favourable for this to be done. Not that it's easy, just that it's possible. If you'd like to support this endeavour, my podcast series or videos, articles, analysis and the rest, consider becoming a Patreon by searching Patreon and my name, Brett Hall, or Patreon and the name of this podcast, Talkcast, or go to www.bretthall.org. There's a link on the front page there that says donate, which makes things really easy. Until next time, bye-bye.